Welcome to Physics 2. Now that you've completed Physics 1 successfully, it's time to work on some new topics. These are topics that you'd find in Physics 2 and the normal college curriculum. So you're going to find that these chapters are much smaller and they're very topical. So using the things that we learned in Physics 1, we can now apply them to specific situations. So our first topic is in Chapter 11, it's fluids. So this is our first lesson, number 1. Now, some of the stuff you already learned in chemistry, so I'm not even worried about it because there's topics there that you've actually previously learned in the land of chemistry. So one of our first ideas is density. So we learned in chemistry density is mass divided by the volume. That's not velocity, we're talking about volume here, the actual size of the object itself. Now, in physics, we normally use the letter rho, which is the Greek letter rho, R-H-O, for density. So if you see this kind of funny Greek symbol, it really means the same thing as D, what we used to use in chemistry for density. All right, now, the first question in my mind is this. What is heavier? Are feathers heavier than, say, rock? So the first obvious answer would be, well, gee, aren't rocks much heavier than feathers? Well, let's suppose, for example, though, I took a stadium and I filled it up with feathers. So it's hard to imagine that could be possible, but let's do it. So in, say, the Citizens Bank Park, we fill the entire thing up with feathers. Is that heavier than, say, just a pebble or a very small rock? Well, sure, feathers are going to be a lot heavier. So how is it possible that feathers could be more, have more mass than, say, just even a rock? Well, the answer is it just depends on the amount of material that you have. So wouldn't it have been a fair contest if I asked you what's heavier, feathers or a rock? Wouldn't it have been fair, maybe a better contest or a fairer contest, if we had the same volume of material? So if I had the same volume of feathers and the same volume of rock, of course the rock itself would be heavier. So to make this an even contest, we have to even things out. A better way of actually asking about that, I'd have to ask, instead of, what is heavier, feathers or a rock, what's the density of feathers, say, compared to a rock? So all things being equal, the rock obviously is more dense. So you have to worry about two things. You have to worry about the mass and the volume of the material that you have before you could actually answer a question like that. All right, now, let's suppose I ask you, what's the mass of a cannonball? So I just happen to have one right here. It's an inertia ball, so it's made out of iron. So if we look, and we look it up in a book, we'll know that the density of iron is 7.8 times 10 to the third kilograms per cubic meter. So that's kind of like a common knowledge type thing. And notice the units that we use for density in physics are kilograms, which is our standard units, and meters themselves, so meters cubed for a volume. Notice kilograms and meter cubed is actually kind of big. So if we look, a meter is this big, wide, by this tall, by this deep. It's a pretty good, substantial amount. So here we're looking at 7,800 kilograms for a cube of iron. It's pretty heavy. It's like a car, much more than that. All right, now, if I'd like to know what the mass is of a cannonball. So if we went out and we got a ruler and we actually measured this cannonball using a ruler, and we noticed that the radius of this cannonball is actually, let's see right here, it's 3 centimeters. So if we take a look, it has a radius of 3 centimeters. So if I draw that cannonball, that radius equals 3 centimeters, also known as 0.03 meters. All right, now the question in my mind is this: how do I actually find the volume of a sphere? Well, let's go back. Let's see, I was a sophomore in high school. I took geometry. Oh, I remember. The volume of a sphere is 4/3 pi r. Yeah, it's a volume. It has to be cubed. All right, so if we look there, the volume of this is going to be 4/3 pi r cubed, along those lines. So if I ask you what's the volume of this, we're going to end up with 4/3 pi, and then the radius of this particular cannonball is 0.03 meters, and we have to cube that. So that will give us our volume. All right, now, my initial question is, what is the mass of the cannonball? So to figure out the mass of something like that, once I know the density and I know the volume, isn't it going to be easy to find m? So let's do a little bit of algebra here. To solve for m, the mass of the cannonball is going to be equal to rho, that's the density, times the volume itself. So we can take 7.8 times 10 to the third kilograms per cubic meter and multiply that by the outcome of this volume, 4/3 pi r cubed, the 0.03, and then cube that. Voila. And I'll leave that up to you to figure out what the mass is. All right, so if I look at this particular cannonball right here, put it on the masser, what would that mass be? All right, now that's a nice example of using density in a formula in a situation. Now, obviously, if I want densities of other materials, I can look it up in a book, and most of those are provided for us.